Hello, my name is Christopher Basan. This is my extracurricular lecture for Dr. Kim's summer class. Lecture by Christopher Basan, that's me. So let's get started. So today's lecture, we're going to be talking about 10 things. What is an object? What is a class? What is a method? What is static mean? What is inheritance? What is an access modifier? What is overloading? What is overriding? What is an abstract? And what is an interface? So let's get started with object. So what is an object? So just take real life objects and programming an object is something. Uh, and programming here, objects are based on classes. So programming an object is an instance of a class. And objects have states and behaviors. So here I made up a little mock-up chart for my objects, which will be cars. So the class is car. And we can make as many cars as we want. But for this lecture, I'm just going to keep it simple and put 2 cars. So car 1 and car 2. Their states will be the color, the brand, the year, and their behaviors will be if they're being driven. So with behaviors, you can use Boolean values like is it on or off, is it being driven, or is it being parked. So here I provided some of that with the cars. So for example, the state, color, red, brand, it's unique brand, year, let's call it 2017. Now, the behavior, is it being driven? Yeah, it's out in the road, there's someone driving it. So let's say with the Boolean value for being driven, it will be 1. And the second car, the color, it's blue, the brand, it's a different brand from the other car. Year, let's say it's a new car, a 2019 car. And the behavior, this one's parked. So let's say the Boolean value for being driven or not, it's 0 to be parked. So here's an example. Here we have a class called animal and subclasses for the types of animals. Here we have dog and cat. So public class testing, when we run this, the animal will be the object. So the animal object, the dog, animal object, cat. So this is to keep the animals separated because as we know, cats and dogs have different states and behaviors. So this is why we're differentiating them. Moving on to class. So what is a class? A class serves as a template for objects and their states and behaviors. Like we did with the cars, here's an example with animals. For example, there's tons of individual objects we use in our daily lives, like bikes, smartphones, and television. So yeah, we have bikes, smartphones, and televisions that we have. Our neighbors may have them too, but they may be different. That's why there's classes for them, because they're all different. They are all different, but there's variations of the same object. Now, here we have an example of that with the dogs, like I wanted to mention. For example, first dog, well, his state, he's not a puppy. He's white. Our second dog, he's a puppy. His color is brown, and so on with the other dogs. They all vary in size, they all vary in age, they all vary in breed. And now a class is like a template for an object, and within it, the features may vary. As you can see here very clearly, the animals have very different features. So here's a coding example. So for example, you could go to Best Buy and there's many different televisions. So an example for that with coding is public class television, and here are the things that vary. String, brand, length, price. When you go to buy these things, well, the brands are the things that vary, the length certainly, and the price too. So for example, this first TV, it's a Samsung TV. It could be length, it could be a 50-inch TV. Price, I don't know, $500. That's unique to this television and the types of television like these. Our second television, it's an LG. Yeah, that would be our brand. Length, it could be a 40-inch, and price a little under 500. So this what can be done with a class. You can make different types of televisions with their different brands, lengths, and prices. Now moving on to method. A method can be described as a block of code that will run when it is called. A class can be full of methods. They are handy because code defined in it can be called many times. Every Java application requires a main method and needs to start the code. This is very true. It's the syntax of Java. Whenever you start a new program, you require a main method. But going back to what I said over here, here's an example. So we have a method called int plus, and here it's integrating an integer called number, which will store a number. So when we call the method plus, inside we have created an integer called sum, and sum will be compromised to making number plus number. So let's say we call it, let's say number is 10, so 10 will go here, sum will be 10 plus 10, and it will return sum. And anytime you want to do the same sum again, or you change the number and you want to do it again, you will simply get, you will simply call plus, and it will return number plus number. So here's a coding example with a string. So we have public class, example class, and it's called static void example method. Inside the method is system.out.println. This method got executed. Here we have our main method that is very important in programming. So here we're calling my method. So what's happening? Here's the example method getting called. The output, this method got executed. My method goes here. This method got executed. Now let's say you wanted to do that twice. You would simply type my method again. And what's going to happen? Example method is called. Example method is called. Just to be sure, it is called twice. Output, this method got executed. This method got executed. As you can see, there will be no errors. The only thing that would happen would be this working twice. And this is really handy in case you want to call a method without having to write any of the insights again. So now moving on to static. Now in real life, static means that something isn't really moving or changing, but in Java, static has no relevance to movement, but it does to no change. And I'll explain it a bit. The word static in Java is a keyword to describe the way things are managed in memory. And now it sounds a little vague, but I'm going to explain it down here in a bit. A static method means that it belongs to the class itself, not just an instance of the class. So it's always going to be the same value in the class. You can use the static keyword to access class variables and methods without having to make an instance of the class. So this means, again, that you don't need to make many instances to get the same information. It's always going to be available. So here's a simple example. Static int number 10. In the class that it's in, the first instance, number equals 10. The second instance, number will equals 10. In the third instance, number will equals 10. In any instance, number will equals 10 because it is static. Here's a coding example. So we have some math being done. And these things here are all static. So at the beginning of the programming, you would import java.language.math. And the math was able to be done because most of the class members in java.language.math are static, meaning new instances from the import of .math were not needed to be created. The methods from .math are all static. So let's look at it really quick. Here we have our main method. Here we have a static class, system.out.println absolute value of -10, math.absolute 10. You would simply use this, input the 10. It's going to give you 10. System.out.println value of pi. It's part of java.language.math. You would simply call it, and then static method would be called. System.out.println 5 squared would show 5 times 5, 25. You would simply input these two numbers, and the static method would do the math, and it would show you the outputs. Here's another coding example. So here's our main method. We're going to create an instance of a static class. Just creating one, calling the method. So hot beverage.hot new hot beverage.hot and the display.output. So here we have the public class hot beverage. You have the private static string node hot beverage that we'll be using a little bit. And the public static class hot tea, it's over here. Display, just gonna come up here. It's gonna first print out hot tea says plus note. What's the note? Hot beverage. So ht display the output. It's helping us do all of these. Well, simply this part, and then this is called hot tea says hot beverage. Now inheritance. In real life, to inherit usually means to receive something or that something has passed down. In Java, it works very similarly, where an existing class has methods and fields that will be used by another class, like passing down. The way this works is with keywords extends on the class that we will use the information from a previous class followed by the name of the previous class. This sounds a little wordy, but I'll show a little example in a bit. Template. There's also proper names for the class that inherits as well as the one who is sharing. This is important to know in case you're discussing code. So the subclass is the one that inherits something. It can be called the child class. The superclass, that's the parent class, and that's the one that shares to the child class. Moving on to the template. So here we have the first class, the superclass, or the parent class. We have all the information inside. And how would you make this a child class? Well, you have class sub, we call it subclass sub. And you have the word extends, and then the name of the parent class. And any information that you have here will be able to be used over here. So here's an actual coding example with cars. So every car has a brand, model, price, and mileage. So this helps us start off with the base car. Now, if you have a sports car, well, this is the child class cars. So something unique to sports car is if they have spoilers. So it's a boolean because if it does have one, it's 1. If it doesn't have one, it's 0. And here we have a class called minivan, and it's also a child class to car. So something unique to minivans is sliding doors. So if it has one, it will be 1, and if it doesn't have one, it will be 0. So these two are separated. So let's say we have like a Ferrari or something, it will go over here. If it had booleans for a spoiler, then yeah, yes or no. We have a minivan, it has sliding door, yes or no. And the information of here is being used over here as well as here. So here are some chart examples of inheritance. So the most basic one is single level, like the template I showed over here. Superclass, subclass. This would be it. Class number 1 would be superclass. Class number 2 would be subclass. Multi-level. Here we have class number 1, which would be the parent class of class number 2. And then class number 2 will be the parent class of class number 3. Here's another example of inheritance. Hierarchy level. Class 1 and class 2 here are the parent of class 3. And information used in class 1 can be used in class 3. Information used in class 2 can be used in class 3, but not in between each other, only in class 3. You have multiple one. This is like the one we showed you with the car. As you can see, this would be the parent class, this 2 would be the child class, and that's being shown here. You could say this is class car, this is class minivan, this is class sports car. And also, I have a more complex way of doing this. I have a class number 1, class number 2, and class number 3 are the child classes of the parent class, class 1, and class number 2 and class number 3. You could say that the parent of class number 4, well, class 4 is the child of these two. But it's important you know how you're going to do things because it can get as complex as this. So moving on to access modifiers. Now, what's an access modifier? Well, an access modifier is simply known as a keyword for the access of member methods or fields. And there are 4 types in Java. There's public, protected, no modifier, and private. The special thing about no modifier is that you could call it the default because public, protected, and private all require you to physically type them in. As no modifier, if you don't type anything in beforehand, it's simply just no modifier. But let me explain what each and every one of them do. So public. With a public access modifier, any other class can access the information, meaning it's publicly open. All across the whole project, any information found within the class that is public, it can be used. Moving on to protected. With a protected access modifier, only classes in the same package can access information as well as subclasses. So this means that information is almost publicly open, but it's not entirely open. It just has a few certain limitations. Now, no modifier. It's similar to protected access modifier, but it's a little more limited. Only same class and same package. What happens to subclass? Subclasses cannot use information from no modifiers. Lastly, we have private. So with a private access modifier, only things from the same class can access the information, meaning anything outside the class cannot be accessed. No subclasses and things like that, only same class. This helps to keep it protected. That's, well, beyond protected. That's why we're using private here and the names for each other over there. Now, this may sound like a lot to remember because there's 4 types and as well as many things where they can go, but I have a chart here that I had to learn and many of my classmates had to learn too to really understand the axis. So here's a chart. Here we have the modifiers and here we have the axis. So let's start with public. Like how I said earlier, Is it available in same class? Yes. Same package? Yes. Subclass? Yep. World? Yep, available there. Protected? You could say it's somewhere Republic. Same class? Yeah. Same package? Yep. Subclass? Yep. World? No. So here's a limitation. No modifier? Yeah. Class? Package? Yeah. Subclass? No. And world? No. As you can see, as you go down, they have more restrictions. Lastly, private. So same class, only same class. Package, nope. Subclass, no. Well, no. I mean, it looked like a lot to remember, but you could simply see that as you go down from public, protected, no modifier, and private, there's more restrictions. Starting with public, it's all yes. Protected 1, no modifier 2, and private 3. So remember this chart, and this will help remember the axis. Now here's a code example of what could happen if you don't remember. So we have a package called package pack. It has a class called A. So what's it gonna do? It's gonna print out a message that says hello. It's very simple, right? Here we have another package called my package. It's having a bunch of imports because they might be needed. Class B, and here we have our main. As we know, this is very important in programming. So we're trying to make a new object, a new A. But here's the problem. There's going to be an error with the object because, as we see here, it's restricted. It's more restricted than what we want it to be used. So that's why it's very important to remember access modifiers, because you can have a lot of code, but if you're trying to get back some information from somewhere else, it could lead to a lot of problems. So like I said, it's very important to remember what each access modifier does, because if you don't remember where to put public, protected, or private, some information could be used somewhere else where you don't want it to be used, or you don't have the access for the information that you want to use. Now, moving on to overloading. Now, what is overloading? Overloading is simply this. So it's simple to explain because it simply is overloading is when there are multiple methods in a class that have the same name but different parameters. So you may think that it might look confusing to have different classes with the same name, that it maybe make errors, but in fact there's no problem with that. So why would you want that though? We will not have to create and remember different names for functions doing the same thing. Now that's very handy because that just means that you have to look back and make more code and all that. But with overloading, things like this can be avoided. If we were to not use overloading, it would mean we have to define method by method different types of sum. So for example, in sum 1, if you want to add just two numbers, well, you have to define it. In sum, you want to make a different sum, you call it sum 2 and add more numbers or more types of stuff. So the thing with overloading is that it saves us on code and all that. So here's an example of overloading in in code. So here we have public class example math, public static int addition in number 1 and number 2. And down here we also have public static int addition in number 1 and number 2, but it has in number 3. Now this one would obviously add and it will return number plus number. So 345 plus 542, 887. And our second one, it's 15, 32, 22. Gives a number like 69. So here's the thing about overloading. It has the same method name, but the parameters are different. In number 1 and number 2, there's only 2. In number 1, number 2, number 3, there's only 3. So that's an example. Now moving on to overriding. So what is overriding? In Java, overriding is when a child class provides an implementation of a method that is already provided by the parent class. But how does this happen? Well, a method in the subclass has the same name, parameters, and signature as the parent class, and the method overrides the method that the parent class has. So here's a code example of what I'm trying to say. So we have a class called animal, public void move, and it's going to print out animals can move, right? Then we have another class, dog, that's an extension of animal. So here's the parent class that I was talking about, and this is the child class. And as you can see, public void mood, public void mood, they both are called the same thing, and they both print out something. So how is this affected in the main method? Well, here we have our public class test dog. This is just to test it and all that. Here's our main method. So animal A, new animal. Uh, for A, overriding hasn't happened yet because we're simply going all the way to animal. So what would the output for that be? Animals can move. That's the line right here. Next is animal B. We made a new one called dog. So it goes to dog. But why? Well, here's where overriding happens. Instead of going, it goes to animal, but the class called dog overrides whatever happens here, and it goes all the way over here. So what happens? The output is dogs can walk and run. That's an example code of overriding. Now moving on to interface. So really quickly, what is an interface? Interface is a keyword used on classes to specify behavior for other classes. And an interface is a group of related methods with empty bodies. Now you may be wondering, how does that look? And I'll show you in a little bit. But why do we use interfaces? So some reasons why we use interfaces is because classes that are unrelated may need to implement an interface, and Java cannot use multiple inheritance, but an interface helps with multiple inheritances. So we can't add extend and extend and extend and extend because that's just not how Java works. That's why we use interfaces. So here's a code template for an interface. We have an interface called bicycle, and this is the comment to know what cadence is. So void change cadence. Here's where we put the value of revolutions per minute. We have one for change gear and new value. Yep. Speed up, another one, and apply brakes. So like I mentioned earlier with empty bodies, here's what it is, an interface. Here's a good example of what one would look like when you're coding. Now, moving on to an abstract. So what is an abstract? An abstract is also similar to an interface. But in this case, it's a keyword used to define abstract classes, which cannot be instantiated, and also methods. And they serve as templates for subclasses. So an abstract class can have abstract methods, member variables, and concrete methods. And that's very important to remember because that's all having to do with Java syntax. And why do we use abstracts? Well, we use that to share code to classes that are closely related. So to not make a mess, we just simply use an abstract class to use the code in between them. Classes that extend an abstract have common methods or fields or may need access modifiers that are beyond public. So these are a few reasons why we need to use an abstract. So here's a quick coding template example of an abstract method. So here's an email one, abstract void move to double delta x, double delta y, kind of like moving x and y coordinates. And that's how a method would look like. Now an abstract class, so public abstract class graphic object. And in here we would add fields and non-abstract methods because you cannot have methods inside that are abstract. I just want to say thank you for listening, and hope this lecture has helped in Java syntax and some uses for them. And yeah, to summarize, we basically used and learned objects, classes, methods, static, inheritance, access modifiers, overloading, overriding, abstracts, and interface. So yeah, thank you.